In this video, we will take a look at how to use these MAX7219 based modules. Let's start with the schematic. Here is the test circuit that I used for an ESP32. The MAX7219 must be powered off 5 volts, so I'm powering it from the VN pin of the ESP32 module. This is a fairly standard level converter board. The left side is for low voltage and the right side is for high voltage. The 3.3 volt rail needs to be supplied to the low voltage side, and the 5 volt rail needs to be supplied to the high voltage side. The ground connects straight through, so you can connect just one side and leave the other disconnected if you want. If you are using a 5 volt microcontroller, then you obviously don't need to use level conversion and the signals can be connected directly through. A word of caution here, there are a lot of sources that say it's okay to connect the MAX7219 directly to 3.3 volt logic. This is actually not true. Since these are inputs, the MAX7219 should not put 5 volts down the pins, so it's probably safe to not use level conversion. This is taken from the data sheet, and as you can see, the minimum voltage for a high state is 3.5 volts. This is higher than the ESP32 supply rail, so it would not be possible to drive a pin high. Having said that, a lot of people have said that it's fine, so you can save a few cents and some board space by leaving it out. Just understand the risks. It may be unreliable, some MAX7219s may not work at all, and if the board has built-in pull-ups, you run the risk of damaging the ESP32. Now, let's take a look at the code. Let's start by downloading this library from GitHub. Now, we load that library. These defines tell it which GPIO pins to use for communication. Using defines to set the pins gives you a single point of reference and makes it easier to change them in the future. The MAX7219 can be cascaded for larger display configurations, so we must tell the library how many we have chained together. And here we create the instance and pass the information to it. These 3 lines are just for initialization. And the main loop just turns random LEDs on and off. There's a lot that can be done without using the library, so this might be a good opportunity to explore SPI in a more direct manner. Let's see what it looks like first though. Here, we are using only the standard SPI library. As with before, we define the pins that we are using, though only CS will be used. DN and SCK are hard-coded in the library. We only define them here for reference. And this is just a weird Space Invader style symbol. This function asserts the CS line and sends the address followed by the value. Here, we set up the SPI configuration and start it running. Note that we have not set the pins. They are hard-coded into the library. The defines for DN and CLK are just there for reference, as mentioned before. These lines are all explained in their comments and essentially just write to registers. And finally, we just write the bytes to display the symbol. If you are planning to use raw SPI writes, it's a good idea to download a copy of the datasheet for reference. Let's see what it looks like. I have embellished this one slightly by adding a second image so that it animates. These types of display are also well supported. The MAX7219 allows you to select several modes that allow 7-segment displays to be used. In these modes, you can write a BCD number to a register, and instead of using it as binary data, it outputs it as a 7-segment digit. I don't have one of these boards at the moment, so I can't experiment with it, but the library handles this for you, emulating full hexadecimal output. The examples provided with the library explain the process, so I won't go into it here.